Hello and welcome to episode 1.4. Today we'll be talking about how to represent inequalities as compound logical statements. So first let's look at how to do one with just less than or greater than signs. So you have, if you look at this, you have two main statements. X is less than 3 and x is greater than 1. So first let's just write this in common form. So if you remember, that's just pretty much representing everything as variables, and then the logical operators as their, the symbols that they're tied to. So all you have to do is just assign these variables. So let's just call this statement P, and let's call x is greater than 1 Q, and then of course you'll have your AND. So therefore your common form is going to be P and Q. So let's go ahead and represent this as a inequality. So right now they are inequalities, but let's represent this as, I believe it's kind of like a compound inequality. I might be wrong, but basically let's just think about what this is saying. It's saying that x is less than 3 and x is greater than 1. So if you had a number line, that's just 1, 3, you have your number line. X is somewhere in this range because it's greater than 1 but less than 3. So the way that you represent this is all you do is you put 1 less than x and x is less than 3. And if you think about it, this is saying the same thing. Because if we look at this, we say that x is greater than 1, which puts it in this direction. And then this also says that x is less than 3, which puts it in this direction, which fills up this same area. So this is how you represent two less than or equal to, or not equal to, less than or greater than symbols connected by AND. So now let's go backwards. So first let's convert this into the kind of English form. So if we look at a number line, and where this is 3 and this is 7, if we look at this, it's the same case. X is greater than 3 because the what is that called? The greater than or less than sign eats the bigger number. So that means it's going to be in this direction, but it's also less than 7, so it's also going to be in this direction somewhere. So if we think about this, our last statement had what it's bigger than and what it's less than. So all you do is you put x is greater than 3 and x is less than 7. So let's go ahead and represent this as a in common form. So again, we'll just say that this is equal to P, this is equal to Q. You have an AND right here, so P and Q. So here's the rule when you have a greater than or equal to or less than or equal to. So if you have two real numbers, x and a, if x is less than or equal to a, this is equivalent to x is less than a or x is equal to a. And if you think about it, let's represent x as being 3 and a as being 5. So let's go ahead and draw a number line. So you have 3, 5. You have your line. So what we're saying is that 3 is less than or equal to 5. So actually no, that's a horrible, I just realized I did this completely horrible. Actually, let's not put anything for x. Yeah, that was a dumb idea. Let's just leave x as x. So x is less than or equal to 5. So you have your number line and you have 5. Ignore the fact that that's not on the number line. So what you're saying right here is that x is either going to be 5, which means it's going to be exactly on 5, or it's going to be somewhere down here all the way to negative infinity. So if you think about this, x is less than a and x is equal to a. So that's not going to be an AND. because let's say that x is equal to exactly 5, then 5 is not less than 5. It's equal to. So if you think about an OR statement, only one of these can be true, except, or at least for an inclusive OR, which I'll go over in the next few videos. So if you can kind of build that intuitive understanding, this would be really easy. So basically you're saying that x is either going to be less than or equal to it. So let's represent this in common form. Let's just say that x is less than a is equal to p, and then the statement that x is equal to a is equal to r. So you have p, because that's the same thing as this. I just realized you can't see my marker. This is the same thing as this. And then you have OR, which, if you remember the symbol, it's just like a V. And then you have x is equal to a, which ties into r, which means p or r. So let's go over some examples with this. So first, let's convert this into English. So again, if you remember, it's going to have an OR, and my computer just jumped for some reason, and that's not the eraser. This is going great. So you have OR, because it's has an equal to sign right here. So the way that I do this is I just put a number line with, actually, I might be dumb for doing this, but let's figure it out. I actually did not work these out beforehand, so if I pull a stupid, don't blame me. Okay, so you have x is going to be less than or equal to 5. Alright, yeah, I'm not dumb. So all you do is just you kind of write the two possibilities. X is either going to be equal to 5 or it's going to be less than 5. So let's just put x is equal to 5 or x is less than 5. And then let's just put this into common form. Let's say that this is equal to p, this is equal to q, and then you have OR. So p or q. Okay, so here's another example. This is not using any equal to. I'm just kind of using this as a bit of a review / bridge. But all you do is you just kind of think about where y would be. So if you have 0, 9, and then you have your number line, that's a 9 by the way, not a 4. You know that x is or y is going to be bigger than 0, so it's going to fill up some of this space, and y is also less than 9, so that means that you have kind of like a closed gap right here. So now you know that x or y is going to be between this range, so all you do is x is less than y, and y is less than 9. And if you look at the number line, these two are saying the same thing. Let's just put this into common form. Let's just say that this is p, this is t. Actually, let's not use a t. T's are used in something called a tautology, and I'll show you what that is in the next few videos. But generally avoid using like t or c or x or y as your compound statements. But let's just say that this is r, and then you have and, so your common form is p and r. Alright, so here's a bit of a complicated example, and this will take a minute to kind of break down. But yeah, let's start with doing a number line. So you have -3 and you have 9. And you have your number line. So there's kind of two things you know. First off, let's just assume that this right here is just the less than sign. So that means that it's going to be above -3, but less than 9. But you also know that this is going to be, or this could be equal to 9. So therefore it's going to be either exactly at 9, or it goes down until it reaches -3. But it can never equal -3 because it's not like that. That's not the eraser. I'm doing great. Okay, so here's what I would do first. I would take the sign that doesn't have the equal to aspect. So all that is just -3 is less than a. So that's pretty easy. But you also know that this can also be true. But if you think about it, this, and let's just say a is less than or equal to 9, this can, or not equal to, a is less than 9, this can also be true, and this can also be true. So let's just assign each of these their own variable name. So let's just say that -3 is less than a is going to be equal to p. Again, we're just storing these as variables because it's called a logical statement, and you're just kind of stuffing all of this inside of this one variable. You have a is less than 9, and we'll say that this is equal to q, and we have a is less than, or actually no, let's put this as a is equal to 9, and I'll show you why in a minute. I could have wrote this a better way, but let's just put this in parentheses so you know what I'm talking about. Is equal to r. And the reason that it says equal to is because if a is equal to 9, then you have, obviously 9 is 9. So let's kind of break this down into how you'd kind of write this. So we know that regardless of whatever, if a is -2.999 or a is 9, it is always going to be greater than -3. So first let's just put -3 is less than a. And I'm going to write the common form below it just to make it look better. So you have p. And we also know that since this entire thing does not affect if, the a is less than or equal to 9, whether that is equal to 9 or less than 9, it does not affect this term. So what you do is you put an and, because x can, or a can also be, or x can be equal to 9 and also fit in the statement that a is greater than -3. So then what we do is we put a parentheses, because now we have a is less than or equal to 9 to kind of dissect. So there's two possibilities: a is equal, either less than 9 or it is equal to 9. So let's just put these as kind of your two possibilities. So and then parentheses. You know that if a is equal to 9, a cannot be less than 9, so you're going to use an or here. So a is either going to be less than 9 or a is going to be equal to 9. And then let's just put this in common form. We know that a is less than 9 is stored in q. So we have q, and then we have or, and then a is equal to 9 is represented as r, and then that's your final kind of compound statement for this inequality. And I suggest you watch this section a few times over, because my explanation wasn't entirely perfect. But if you can kind of understand that regardless of whether a is equal to 9 or less than 9, it is always going to be greater than -3, and that's why you use this and statement here. So here's kind of the final takeaway. When you have a less than symbol, or less than or equal to symbol, or greater than or equal to symbol, it's equivalent to x is less than a or x is equal to a.